This episode of Mathematics with Mr. Richardson has been brought to you by Hilton Hotels and Resorts, downtown Anchorage, Alaska. Reminding you, at Hilton, if you're not satisfied with your stay, let us know, and we'll make it right. Rational expressions. You can multiply them, you can divide them, but did you know you can add and subtract them? You will soon. In section 8.5, adding and subtracting rational expressions. The objective of this section, to add and subtract rational expressions. Lesson vocabulary, complex fraction. And an essential understanding. To operate with rational expressions, you can use much of what you know about operating with fractions. And a quick review of the concept of least common multiple. We know that the least common multiple of 4 and 6 is 12, but do you ever consider why? Well, it comes down to the prime factorization. In this case, 4 is 2 times 2. Note those are the prime factors of 4. 6, 2 times 3. The least common multiple, therefore, of 4 and 6 is 2 times 2 times 3, which equals 12. Note the vertical alignment of these prime factors. The 2 is only counted once in the left column, once in the middle, and then the 3 is counted once, it only occurs once. Similarly, the least common multiple of variable expressions, 4xy, can be rewritten in this way, 6x squared, rewritten in this way, vertical alignment, and multiplying those prime factors arrives us at the least common multiple of 12x squared y. Example problem 1, finding the least common multiple. What is the least common multiple of this expression and this expression? To start, take a look at step 1. We would write the prime factors of each expression. Move on to step 2. Write the product of the prime factors. This is the same as we did in the previous slide when we reviewed least common multiples, but note the 2 squared in the first expression and the 2 raised to the first power in the second expression. The 2 squared will be the factor pulled into our least common multiple. We have a 3 and a 3 squared, so the higher power of 3, 3 squared, will be in our least common multiple. The same continues through the variables and also through the binomials. Note the x plus 1 squared in the first expression and only an x plus 1 in the second expression, and the x plus 4. After this, it's simply a matter of multiplying and simplifying to find that the least common multiple is 36x squared y cubed times x plus 1 squared times x plus 4. And your first opportunity to show that you have got it. Question 1. What is the least common multiple of the expressions 2x plus 4 and x squared minus x minus 6? And got it question number 2 of 2. What is the least common multiple of the expressions x squared plus 3x minus 4, x squared plus 2x minus 8, and x squared minus 4x plus 4